Welcome back to the Explainer. So if you caught our last one, you've already nailed the mechanics of loading and saving your datasets. But today we have a very specific, absolutely critical mission. We are going to establish a non-negotiable habit, inspecting your datasets the very second you load them. This is where we build the core exploratory toolkit that you should be deploying at the start of every single new project.
Picture this. Your code just ran perfectly. No errors, the file was found, and the data is sitting right there in memory. It feels like a green light, right? Are you ready to analyze it? Well, the answer is a resounding no. There's this massive and frankly dangerous assumption among beginners that perfectly loaded data equates to safe, clean data. But look, just because the computer read the file doesn't mean the information inside makes any logical sense. Without rigorous data forensics right out of the gate, you could easily spend hours running models on completely broken data.
Here is our exploratory roadmap for today. We'll hit 1. The vital inspection habit. 2. Surface-level sanity checks. 3. Structural and statistical scans. 4. Missing data and uniqueness. And finally, 5. The complete exploratory toolkit.
Section 1. The vital inspection habit and the danger of flying blind. When you first load a dataset into Pandas, you really need to treat it like a patient arriving at an ER. You wouldn't just rush a patient into surgery without taking their vital signs first. In the exact same way, before grouping variables or building complex models, you have to use your Pandas toolkit as a set of diagnostic tools to uncover invisible underlying data issues.
Which leads right into Section 2, surface-level sanity checks, or our initial triage. When your data first arrives, you want a really fast visual confirmation that nothing broke during the import. The two most common commands for this are head and tail. They do exactly what you'd think, pulling the first and last few rows of your dataset. It's just a quick check to verify that your columns have the right names and that there aren't any glaring structural formatting errors.
Now, while head is standard practice, sample is often the vastly superior command for spotting actual issues. Why? Well, because the first few rows of a dataset can look deceptively clean. If someone was testing their own data entry, those top 5 rows might be absolutely perfect. But what happens at row 5,000 when they got tired? Sample gives you a randomized reality check, pulling rows from anywhere in the file. This completely breaks you out of the trap of assuming a massive dataset is as pristine as its first 3 lines.
Moving into Section 3, Structural and Statistical Scans, or the Data X-ray. We've done our initial triage, but now we need to look beneath the surface. To do that, we rely on what is honestly the single most useful first command you can ever run on a new dataset, df.info.
Understanding exactly what df.info exposes about your dataset's anatomy is a real game changer. In one quick glance, it tells you your total row count, provides a non-null count to instantly highlight missing values, and shows the data type for every single column. And that last part is so vital. Are your numbers actually stored as integers, or did a weird character sneak in? If Pandas sees even one letter, say someone randomly typed IDK in an age column filled with 1,000,000 numbers, it defensively casts that entire column as a text object. Catching that right now saves you a massive headache later. Make it a habit to run this before doing anything else.
So while info gives you the structural anatomy, df.describe is its essential companion for a statistical scan. When you run df.describe, Pandas automatically finds all your numeric columns and generates a fast summary table. It outputs the count, the mean average, the minimum, the maximum, and 2 incredibly important metrics, the standard deviation and the quartiles.
Let's really deep dive into why describing is so powerful. Standard deviation and quartiles work together to expose the actual shape and spread of your data. The quartiles basically chop your data up into 25%, 50%, and 75% markers, while the standard deviation tells you how wildly your numbers vary from the average. Here's a golden rule for you. If your standard deviation is wildly larger than your mean, it's a massive red flag. It means your data is heavily skewed or riddled with errors. This statistical scan instantly flags impossible outliers, like a maximum age of 999 or a supposedly positive value dropping to -50. Which brings us to Section 4, Missing Data and Uniqueness. We are moving from the broad X-ray to targeted biopsies. We're going to run granular health checks to hunt down the specific anomalies that our structural and statistical scans might have merely hinted at.
The absolute most precise tool for uncovering gaps in your data is isnull.sum. Under the hood, here is how this works. Isnull scans your data and returns a true for any blank space. By chaining .sum onto it,
Pandas treats every true as a 1 and just adds them all up. It doesn't just tell you data is missing, it mathematically quantifies exactly how much missing data exists in every single column.
Imagine running that command and bam, a stark number flashes up, 4,502 missing values in a critical column. This right here is why running this command is a crucial early warning system. If you know that half of your target column is entirely blank, you know immediately that you cannot proceed with the standard analysis. You have to pivot to handle those gaps. This simple command literally prevents you from building a house on a foundation full of holes.
Next up in our targeted biopsy is unique. This little command tells you exactly how many distinct, unique values live in each column. Think of it like a funnel sorting distinct shapes into buckets. It's highly critical for translating abstract data into real-world insight because it distinguishes continuous data from categorical data. If a column called status has a billion rows, but unique returns the number 3, you immediately know it's a categorical column, probably something like active, pending, and closed. Understanding this distinct footprint dictates exactly how you will analyze it.
And that brilliantly illustrates our final deep dive command, value counts squared. When you run this on a specific categorical column, it counts up the frequency of every single category. Now, while it outputs a table of text, you should really think of it as your very first rapid-fire visualization. It immediately reveals the proportions of your data. It is the single greatest tool for spotting typos, like when male, lowercase male, m, and a blank space are all accidentally logged as separate categories. It also exposes severe class imbalances. If 99% of your transactions are legitimate and only 1% of fraud, you absolutely need to know that imbalance exists before you start your work. Section 5. The complete exploratory toolkit. We are going to bring all of these isolated diagnostic commands together into a single, cohesive checklist that you can use every single day. All right, here is your definitive diagnostic checklist. Step 1. Get a fast look and break the illusion of perfect data using head, tail, and crucially, sample. Step 2. Run info to understand the structural anatomy and data types. Step 3. Use describe to scan for statistical outliers. Step 4. Quantify the exact gaps in your data with isnull.sum. Step 5. Understand your categorical boundaries with unique. And Step 6. Hunt for typos and class imbalances with value counts. Honestly, running these 6 commands takes mere seconds of your time, but it literally saves you from the total disaster of working with data you don't actually understand.
So, now that your data set is fully diagnosed, what comes next? Well, in the next part of this series, we will get into the treatment phase. We'll explore selecting and filtering data using .lock, .ialock, and Boolean filtering, because once you know exactly what is wrong with your data, you can confidently apply these techniques to isolate, extract, and eventually fix it.
I want to leave you with this provocative thought. If it only takes a few seconds to run this 6-command toolkit, what is the true cost of skipping them? Skipping this step doesn't save you time, it just delays the moment you realize your entire analysis is flawed. The best data professionals aren't just good at math, they are highly suspicious of unexamined data. So adopt the habit, run your diagnostics, and know your data inside and out. Thank you so much for joining me on this explainer, and I will see you in the next one for selecting and filtering.